For my students, this is one of the problems in your homework tonight. I'm going to do part A in green, and then I'll do part B later on in blue. So part A is asking how many moles of zinc carbonate, here it is, zinc carbonate, and citric acid, if you read the question, it tells you the names is zinc carbonate and citric acid, are required to produce 30 moles of your zinc citrate. So that has that in the name right here. And this is not a compound we typically work with or have seen before. So make sure you definitely go through and read the problem and use that to figure out what exactly we're looking at. So these are 3 compounds we don't see. You don't typically know the names of it, which is why it provides that to you. But you should know your water and your carbon dioxide. So this question, part A, wants to know 2 things. It wants to know moles of zinc carbonate, and it wants to know the moles of citric acid. So this is a 2-parter within part A. And we need to produce, it says, 30 moles of the zinc citrate. So always start with what's given. We have 30 moles of zinc 3, and then your C6H5O7 2, and we have a 2 there because of crisscross. You're crisscrossing those charges. And I know it seems like a lot to write all that down, but trust me, get into the habit of it, because when you start converting to grams, you want to have the correct thing written here, so when you grab those values from the periodic table, you end up with the correct thing. So we're starting off with this, and first we're going to look for how many moles of zinc carbonate that produces. So in order to do that, we're going to look at our mole ratio. So I'll need moles of our zinc carbonate. Moles of our zinc citrate on the bottom, because whatever's in the top of the first fraction must be written in the bottom of the second fraction. That's what stoichiometry is all about. You want to cancel all that out. And then we're going to use our mole to mole ratio to find the moles of zinc carbonate. So one mistake that I noticed quite a bit today as we were going through practice together, I had quite a few of you going from moles to grams. But keep in mind, it's providing you with a different compound that it's asking for, and it's not asking for grams. Even if it was, in order to get from one compound to another, you have to use your mole ratio. And that mole ratio we get from our equation. So anytime you're going from one compound to another, get to that mole ratio. So you get our mole ratio from our balanced chemical equation. This is our first compound, and there is nothing in front, so we assume that's a 1. The second one, our zinc carbonate, that has a coefficient of 3. So technically, even though I said I wasn't going to work this out in detail, you can multiply that pretty quick, and you can get 90 moles of zinc carbonate. But that's just part 1. That's just part 1. There's another one, part 2. We're going to start with our 30 moles of our zinc citrate. ZN3C6H5O7. Except this time it wants to know how much citric acid is required to produce this amount. So we're going to do the same thing as before. I know we have 1 mole because that's what we had in our previous conversion, and that is the coefficient. We're going to use the mole ratio again because we're going from one compound to another. And the other compound we're going to is our citric acid. That's our C6H5O7. And the coefficient on that is 2. If you look at our original equation, our balanced chemical equation, that will be 2, giving you a total of 60 moles of C6H5O7. So that's all part A. It's just a mole-to-mole conversion, and the mole-to-mole conversions are much quicker than the other conversions that we've been doing, like this next one. This next one's going to be kind of long, so I'm hoping I have enough room here. So part B, we're going to do in blue. It wants to know what quantities in kilograms of H2O and CO2 are produced by the reaction of 500 moles of citric acid. So this I may not have room for, so I'm going to be experimenting here as far as how I'm going to do this on this program. First, let's start with our given, 500 moles of our citric acid, that's C6H8O7. And what is it asking for? It wants to know in kilograms of H2O, then it wants to know kilograms of CO2. So let's do our H2O first. I know kilograms is kind of tough, but we can do that at the very end. Let's focus on getting grams. So we need to go from citric acid to water. In order to go from one compound to another, we have to have our mole-to-mole ratio, or our mole ratio. So this is our mole of C6H8O7, and we need to go to moles of H2O. Looking at our coefficients, it looks like our coefficients of citric acid is 2, and our coefficient of water is 3. So that way these now cancel out. I didn't really do that before because we didn't have too many steps. So in order to get the mass, we need to go from moles on the bottom, and we put that on the bottom so it cancels out with the moles on top over here. Moles of H2O to grams of H2O. You get that from your periodic table. And anytime you get a value from your periodic table, it's always going to be out of 1 mole. I've had quite a few people today ask me, well, what about this 3? There's a 3 right up here. Shouldn't you include that when you talk about the grams from the periodic table? And I would say, yes, you do. You do that in your mole ratio, so you don't have to do it again here. So I remember the molar mass of H2O is oxygen, which is 15.99. plus 2 hydrogens, which is 2.02. That's going to get me 18.01 grams. I only remember that because we have done it today quite a few times. So that's going to be from our periodic table. Now we can cancel out our moles of H2O, and now we have our mass. But the problem is it's asking for the mass in kilograms. And this is going back to your dimensional analysis from so long ago. So you can do the same thing as before. You can do grams of H2O on the bottom. You want kilograms of H2O on the top. And how many grams are in a kilogram? It's going to be 1,000 grams per kilogram. You can cancel out your grams. And I'm going to just leave it like this. If you would like to calculate it on your own, you would multiply 500 times 3 times 18.01. And you would divide that by 2,000 because in our denominator you have 2 times 1,000. So that's how you set that part up. I believe I can squish this last part in here too. We're going to do the same thing again, except we're going to calculate the kilograms of CO2. We're starting off with the same amount, moles of our citric acid. And we're going to set this up pretty much the same way. If moles of citric acid is on top, I need that on the bottom. And that's going to be 2. Except if I'm looking for moles of CO2, I'm going to have, well, in some cases you would have a different coefficient, but it just so happens to be the same as water in this circumstance. So the coefficient is 3, and that's what we're going to use. And again, we can cross this out, and now we can go from moles on the top of this fraction to moles at the bottom of the fraction. But here, I am at a bit of a dilemma, you see, because I don't have this memorized as far as the molar mass of CO2. So I have an app on my phone, and it is called, let me see it real quick, Quick Elements of the periodic table. I'm going to pause the video real quick and do my calculations so I don't waste your time, but I'm going to calculate the molar mass by taking 2 oxygens, so that's 15.99 times 2, and add that to 1 carbon, which is 12.01. All right, for this calculation, I got 43.99 grams of CO2. I can cancel that out with my moles of CO2, and I have just one more calculation left because don't forget, this original question is asking for my answer in kilograms, and we're going to have the exact same thing here. So we're going to multiply this by 1,000 grams of CO2 under 1 kilogram of CO2. We can cross those out, and that will get me the final setup. So this is how I'm going to set up the final answer. Now, I'm not going to calculate the final answer because your quiz tomorrow, I'm not going to look at your final answer. We're just looking at how you're setting it up. So as a review for some of you, in case you forgot and you wanted to study and practice, I'm grading you on a few things. I'm grading you on, are you starting off with the given? Are you using the correct conversion factors? That's one main thing. The other two main things are kind of combined together. Are you labeling everything correctly? Your moles of C6H8O7, your moles of H2O, your grams of H2O. Are you writing all those labels down correctly? And are you writing them all down? So don't forget to write those down. Take time because that's what I want you to practice. If you have any questions, go ahead and post on the Edmodo wall.